get started. I would like to introduce KYZEN's own Kevin Buckner.
Thank you, Chelsea. I appreciate that. All right, good morning, good afternoon, good evening from wherever you're joining me today. My name is Kevin Buckner, as Chelsea said. I wanted to put together a presentation for you guys today, it answers the questions and a major question that we get asked every day when we go into a facility, especially contract manufacturing facilities. It's how do I clean no-cleans and water solubles in the same process? And this is a challenge that is not for the faint of heart. So first off, let's define what water soluble is. A water soluble, an organic acid, and no, it's not plop, plop, fizz, fizz, or water relief it is. Water soluble flux is also called organic acid flux. So you see WS and OA interchanged a lot within conversations when we start talking about this. Water soluble organic acid, it bonds with the PCB and metal surfaces which require cleaning. You're leaving organic acid, which is a fantastic cleaner. So your pad is very clean, but you have to remove that or you will see some type of etching. Organic acid is more reactive than no-clean or rosin fluxes. It's a very, very reactive flux, in fact. Organic acid flux actually absorbs water from the air, which can create ionic issues, which we're all trying to avoid. Organic acid flux also has a considerable amount of surfactant in it. And surfactant, for those of you that know, surfactant means probably foam. And if you do have foam issues, take a look on our Tech to Tech website, because there's past sessions about foam and how to handle foam. And when we talk about foam, what we are talking about is the really tiny little bubbles, not the big bubbles like in a bathtub. We talk about real tiny bubbles, and those tiny bubbles all merge. We add a silicate defoamer. Don't use silicone. Silicone is the #1 defoamer in the world, but don't use silicone. Use a silicate material set, and we enlarge those bubbles and pop them in the environment. That's how we get rid of foam. So now we've done that, let's talk about no-cleans. And no-cleans are typically nomenclature is NC, and it's not the fact of just because it says no-clean, you don't have to clean it. So there's other things that go around with that. But no-clean flux is made from man-made resins, typically. That's what no-clean flux is about. It does leave some type of residue. It leaves a benign residue. It's not no residue. It also leaves low ionics. It's not no ionics. Multicore came out with the term no-clean. Everybody went with that, but it doesn't mean there's nothing there. It just means there's low volumes of it there. If you don't clean the board, aesthetically, it can look very dirty. That material set, that flux will stay on the board. And make it look like it's an unfinished type product. And that's not good for you guys, especially if you're in contract manufacturing. No-clean leaves a hard encapsulation of metal salts. And that's actually not a bad thing. That's not a bad thing. Because all the encapsulated metal salts are encapsulated, you won't have that ionic issue, which presents a dendritic, could present a dendritic kind of problem for you. No-cleans also are defined as hydrophobic. And hydrophobic, you know me, you know my terminology, means it repels water. It does not like water. So it's trying to push it away all the time. So simple terms, water soluble organic acid flux, it's solubilized in water. So you don't need a cleaning agent other than water to actually clean it most of the time. Low standoffs and all types of some BGAs and QFNs and window pane devices, you're going to need something. You're going to need some help with those. But typically, no-clean flux is typically a man-made resin material set that repels water, and that's all of the time. So you are going to have to use some type of chemistry to break down that no-clean material set. So let's get back to that. Let's answer that question. How do I clean no-clean and water-soluble flux in the same process? Easy, right? Yeah, not so fast, my friend. If you have a system that is only capable of running water, you can only clean organic acid flux. That's purely by definition. So if your system looks like what we're talking about on the screen, where you have a washer or wash tank and that returns water back to carbon and mixed bed and then brings it back into the washer, the bad news is you can only clean water solubles. And typically they measure the cleanliness based on like conductivity, where you clean the water before it goes into the process itself. You import your boards into the batch or into the inline. You measure the conductivity of that water as it comes back through the material set. When that water gets back to a clean level, then you know you've got some clean product. The problem is if you're trying to clean a no-clean flux, where you have to solubilize that resin material set or rosin material set, you have to use some type of chemistry to do that. I always go back to look at the Christmas tree. When we cut the Christmas tree off and we get the sap over our hands, put those hands under the washing machine, under the faucet with just hot water and see what happens. Nothing. Add a little bit of soap to that, you get that surfactant, saponification happens, and all of a sudden the flux is gone. So the thing you have to evaluate is, do you have the capabilities? Do you have the capacity with your equipment to actually incorporate some type of chemistry into your wash? So as you see on the bottom right, we have a batch style cleaner, which has a concentrate tank, which premixes and moves it over to the washer side. On the second picture, we have an inline machine, but they have one of the KYZEN blue drums pumping the material set into, so the machine can actually pull the chemistry into the process itself. If you have this type of setup, you are good. You're ready to go, because as the diagram will show us, the water will come in, run through the DI beds, go into the rinse tank, run all the way through. Typically that will return back, and then the washer tank will actually move its material set back over there as well. So another thing to consider is, do you have chemical isolation? If so, you can clean your no-cleans. Some people call this a closed loop type system, where you have wash tank storage area, which has your pre-mixed chemistry or your 15%, 20% chemistry stored inside that. It goes to a washer tank and then gets reused, and that's closed looping. And then other people call things like a chem iso section. Do you have a chemical isolation section, where you're using chemistry in your washer tank, but you're actually using either air or air and water to separate those two parts completely out, a washer tank and a rinse tank in a single inline style piece of equipment? So Kevin, what's really the answer? In simple terms, if you use chemistry to clean your no-cleans and rosin-based fluxes, you're golden. You are not going to have a problem cleaning water soluble. Unfortunately, if you only clean water soluble fluxes with water, you can't clean no-cleans or rosin-based fluxes. You have to incorporate chemistry into your process somehow. Is that the end of the debate? No, I don't think it is. Because if you take a look at our process here, the process on the right, to the right of the plus sign, is a standard washer type system running just water. The interesting part is people have come up with different types of additions that you can put in front of those processes now, incorporating a chemistry style only washer. And typically that would look like something like this type of a setup, where you'd have a chemistry machine in front of your existing washer. So there is a solution. Don't panic. If you're contract manufacturing and you need help, you want to get into the chemistry business, you may be being forced to get into the chemistry business, give us a call. We'll be happy to help you. That's all I've got. Just a real quick session. I will turn it back to Chelsea.
Thank you, Kevin. If you would like to discuss this topic further, please contact your local KYZEN regional manager, or send an email to tech@kyzen.com, and we will have one of our cleaning experts schedule a follow-up with you as soon as possible. Again, we thank you all for joining us today, and we hope to see you again soon. Stay safe, stay healthy, and have a great day.
Thank you.